Okay, ladies and gentlemen, good afternoon. No, good morning to all of you today. We're going to start something amazing today. I even put a worksheet on my, it's kind of odd. I was looking for, I know I have something somewhere. I can't find it on my computers. I hope that it just didn't, I lose it when I crashed. In other words, my computer crashed once and I lost some things. But we're going to talk about antiderivatives. And so you go, oh my God, antiderivatives. Oh no. Oh no, they're actually pretty easy. Oh, I love them. They're easy. Antiderivatives. You go, oh my God, what in the world is an antiderivative in the first place? Right? Well, this is kind of like the second part of the calculus course in some ways, Calculus 1 and the basis of Calculus 2. Is antiderivatives. You go, what's an antiderivative? So we're going to start by a definition. And we say big F of x is an antiderivative of our function f, okay? It's all on an interval I. So on some interval I, and you go, well, what is that interval? Well, it's going to be from A to B. Okay. If the following is true, okay, that if I take the derivative of that function, it's going to equal to the function f for all x in the interval I. And you say, well, you're defining this interval to be from A to B. Yes. So this is what we call the definition of an antiderivative. And big F is the antiderivative. But notice in the definition what that really is. That's saying that you have to differentiate some function f, okay, and it equals f. I mean, that's essentially what they're saying here, because that's what you see here in the definition. And it's the antiderivative of this little f function. And it really isn't that hard. It's actually the opposite of a derivative. So if you said to me, what does it kind of feel like? It's almost like saying we have the opposite of a derivative in some ways. Which is why they call it an antiderivative.
So it kind of like changes the derivative back into its like own original equation.
Eventually, yeah, but it's like you say, what's the meaning behind the word anti, right? You go, anti, what's an antiderivative? Well, it's kind of like, in some sense, the opposite of a derivative. And, but it's called an antiderivative. And it's for a particular function, and that's the f function in this definition. So here's your f, right? And this whole thing's that, So, I mean, that's what we call an antiderivative. And then they'll give you this very important fact. And I think I just probably want to say it now. Well, actually, let's give you guys a quick example. If you say, what is an example? Or I should say, no, let's do this first. No, let's do an example here, right? How about if we do this here? I'm going to introduce you guys to the very first rule. It's going to be what's called the power rule. And it's a power rule for what? Antiderivatives. This is essentially where you start your career with antiderivatives. And, the interesting thing is, if you could do arithmetic, well, then you could do antiderivatives. Easier said than done. You go, really? What's the power rule? Well, let's see what your book wants to give you. Okay. Here's the deal. I'm going to write it this way. Right? So on the left side, here's your function. X to the n, where n could not be -1, okay? And on the right side, I'll give you the antiderivative here. Take x to the n plus 1 over n plus 1. Okay? Now, this is called, by the way, the what? Your power rule for antiderivatives. Okay? Now you might have said to me, Mr. Judge, what are you talking about? If I can do arithmetic, I can find an antiderivative. Well, you see that power n? What happens to n? You add 1 to the power and you divide by the new power. So you might say n plus 1 is a new power? Yes. Okay? That's your new power. And you have a denominator now. It's the same value. Okay, so let me actually remove that phrase on the bottom because there's not a power there, but your new power is n plus 1. There's your new denominator. So if you can do arithmetic, you can find an antiderivative. If you can add 1. But it's easier said than done. You go, what are you talking about? I'll give you an example. And by the way, that's kind of like the opposite of your power rule for a derivative, if you guys notice that. It's the complete opposite of that. So if they give you something simple like x squared, and really, this is the f function. I'm going to say f is really what? X squared here. Can you use the power rule to find that antiderivative function, f? It's a big capital F. F is the antiderivative. What do you guys have to do this? You take the 2 and you do what with the x variable? You take the 2 and you add 1. Is that true? Then you divide by 2 plus 1. So what is your antiderivative now? It's x cubed over 3. Easy peasy lemon squeezy? That's it. Anyway. So I want you guys, let's do a note here. You say, well, why is that an antiderivative, right? You go, does it satisfy this definition? That if I differentiate the big F, it equals my original function? I don't know. Let's try it out. Because this is the definition of an antiderivative right in here. I wanted to get this going for you guys so you have weekends and weekends of studying antiderivatives. Because that's really the second part of the course in some ways. You talk about differentiation and integration. This is related to that. This is actually integration. But okay, so that's why if you say, is this differential and integral calculus? Yes. Anyway. Okay. So let me show you guys what this is. They're saying that if you differentiate what? The big F, the antiderivative function, I should get the original function f. Is that true? Okay, do you guys know how to differentiate? Pull out your constant. What do you get? That 1/3 3x to the 3 minus 1. Isn't that x squared? And that is your f function that they gave you. Okay, so I want you guys to see exactly that definition that I just gave you guys. This is the definition of the antiderivative. Wasn't that the original function they gave us here? Say what? Yes. So what is your antiderivative? It's right here. That, ladies and gentlemen, is what they're looking for, big F. The anti what? Derivative. Easy peasy lemon squeezy. Well, and I'm going to give you guys another note, and I say, by the way, maybe. This is something we're also going to get used to, okay? If I know the antiderivative is x cubed over 3, or 1/3 x cubed, right? For that original function. Do you guys know what is also an antiderivative? I can add a constant c, okay? This c is going to be something we're going to have to get used to. C is just a constant. What's another? That's a fancy way of saying what? The constant is a number. 5, -6, 2, 1.3, pi, 18, 4/5, -4/5. It's just a number. And what I want you guys to notice is that if I differentiate one-third x cubed plus c, where c is a constant still, what do you guys notice we end up getting? We still get what? The function x squared. That is f. That's the original function that they gave you. Okay, you guys with me on that? So you might say, boy, Mr. Judge, what did that just do for us? Well, this is known as the general antiderivative. So you might say, what is that? A general antiderivative. When you add a constant, because when you differentiate a constant, isn't that 0? You guys with me on that? So we don't really want derivative. We don't really want, ladies and gentlemen, just the antiderivative. You want the general antiderivative always. And so your book will give you a fact here really fast, and you start that section, and it says this. It's the general form of the antiderivative. They call it a theorem. And they say it this way. If big F of x is the anti-what derivative, always run out of space. That's kind of one of the reasons why I remember thinking of yesterday, I made that little weird mistake with the algebra, because I'm always trying to squeeze everything in, and I can't. And then I can't really see it as well. So I'm not going to do that anymore. Antiderivative of f on I. Okay? That's how your book wants to write the fact. Then it says the most general. Then the general solution, or the general antiderivative. Is f of x plus c, where c is a constant. C is a constant. Okay? And that's just exactly what I gave you, in all honesty. This is a general antiderivative by definition. And that's what you always want, the general antiderivative. And the notation they use is this capital F. Okay, so this is the general antiderivative. Easy peasy lemon squeezy. So you might say, okay, Mr. Judge, let's look at some more examples. They're going to give you some functions. They want the most general antiderivative. Okay? Let me give you the easiest one to do. What's the antiderivative here? General. What's that going to be? Well, what's the power? You go like say, I don't even see a power here. You got to know a little algebra. The dirtiest word in math is algebra. What's the power for just x from beginning algebra or even pre-algebra? Right? What's the power if they just give you an x? 1. Good. Okay. So what do? You take the x and you take the 1 and you add 1. But don't forget to divide by that same number, 1 plus 1. Plus that c. Ladies and gentlemen, what are you going to get? 1/2 x squared plus what? C. Here is your what? General antiderivative. What do you guys think about that? Is that pretty good? Easy peasy lemon squeezy? You say, is this just based on arithmetic? Yes. All right. There's an easier antiderivative. What if the original function they give you is 1 and you go, I don't even know how I'm going to use this what? What are we using? This power rule. The only restriction is that n can't be -1. Okay. How do we use the power rule? Does anybody know? Go back to beginning algebra. Yes. Isn't this what? Told you. Okay. So, what does that give you then? You take 0 plus what? 1. You divide by 0 plus 1. Add your constant. What's your antiderivative, ladies and gentlemen? And then just x plus c. What do you guys think? Easy peasy lemon squeezy? So you had to remember a little bit of beginning algebra. Alrighty. You guys ready for more? You say, then why do people really not like antiderivatives? And I'll say, I don't know. Square root of x. What do you guys get? You're going to have to remember a little bit of some what? Algebra. Is that right? So what's this antiderivative going to be? You take the power 1/2 and you add what? 1. You got 1/2 plus 1. Don't forget to add your constant. So I'm just going to kind of go back and emphasize what we did here, okay? This is my new power, and then this is a new denominator as well. So what I say to you is, you're going to have to learn what? Arithmetic with fractions. You might say, really? What is 1/2 plus 1? Is that 2/2? Don't you need to have the same denominator? You guys okay with that? And so now, what is 1/2 plus 2/2? Isn't that 3/2? Okay. You guys good with that? You guys okay with that? However, you have more arithmetic to do. You go, oh no. What do I mean by more arithmetic? What kind of arithmetic do you guys do here? What is that? What are you guys looking at? I do my algebra and arithmetic in purple. I've kind of got into that habit. What happens when I ever divide by a fraction? I'm dividing by 3/2. Do you guys agree with that? How do you take a whole number, divide by a fraction? You multiply by the reciprocal of the fraction. Is that true? Okay. So I'll give you guys a little bit of algebra here. So what that now means here is your antiderivative function will be what? 2/3 x to the 3/2 plus c. So, ladies and gentlemen, here's your what? Antiderivative function. And you might even look in back of the book. Now, this answer is fine, right? But if you look in back of the book, what might you see? You might see what? This answer. Why do you guys think you see this answer? You go, I thought it was x to the 3/2, and I'll say it is x to the 3/2. But what did they do? Do you guys know? Didn't they simplify? Do you guys know what I'm saying? So there is a little bit of algebra, beginning, intermediate, and and arithmetic. I think sometimes, again, like I said, I've always harped on this stuff. I think that is sometimes for some people the issue. And how do you fix that issue? Well, you do a lot of questions. You do a lot of problems the way you do. That's what I did. But you don't do it the night before. I mean, there are people like that. They go, Mr. Judge, I'm not going to. There are people who tell me things, and they've always done this, and they think they're impressing me, right? So you know what, Mr. Judge? I'm not going to sleep. I'm going to study for this test. I'm not going to sleep. And, I say things to people that blows their mind. Even some students say, you shouldn't say this. I've said this once. I remember a student, it was last semester. Was it last? When was it? It might have been spring. Yeah, in a trig class. I said, you know what? If you're going to do your homework the night before a test, you might as well not do that. Just go out and see a movie, have a nice dinner. Go have some fun. Why would you not sleep the night before a test? Because that's when you're going to get started on everything. When I say those things to people, they look, you shouldn't say those things. I go, well, why not? What's the point? By then, I think it's a little too late. The point is, who do you think you're kidding? Because you're not kidding me. If the night before a test is when you first start doing this, I'd say, why do you stress yourself out? Just go to the movies, have a good time. Because what happens is if you don't sleep the night before a test, what's going to happen? You're gonna blank out anyway. Your brain's going to go to sleep on the test. That's a little thing that people just, my whole career, my whole life, people do that stuff. And I've been preaching, because you're doing a little bit of this arithmetic. And even if you said, hey, I have a little trouble with arithmetic, the only way you can fix that is going over this process over and over and over and over again until you can do it in your sleep. That's the only way you can do it. And so it does mean you have to do a lot of questions, and you got to give yourself time to do it. But this stuff can be very simple if you've done the right things for yourself. It can be very difficult if you don't. But there are people who will not make things easier for themselves. They have to make things harder. And that's a very philosophical thing to say that applies not just to calculus, math, or anything. That applies to life. You're going to run into people like that. I know people like that. And we all are a little bit like that at things. Even I am a little bit like that at some things, but not with math. Not with this. I'm not like that. This is why you'll see me grade your exams fast. I have people who have said to me, you're like the fastest grader I have ever seen in my life. Sometimes instructors don't give you your test back till even the next semester. I don't know why. There's something wrong with them. You can tell them that. You can say, you can even mention my name. Mr. Judge, think there's something wrong with you. Because there is. Why can't you get a test back? Do you guys see my point? Sometimes those instructors don't like to see me. Because I tell them too. I say, hey, what are you talking about? You don't give you're too busy? Doing what? What are you busy doing? This is your priority. If you tell students to make it a priority, you got to make it a priority. It's just good leadership, ladies and gentlemen. That's just the way it is. That's why you see me the way I am. This man doesn't sleep because I got 3 jobs. Not really, but. Huh? Sure feels like it. I've never stopped being a student. Sure feels like that. You guys have no idea. And the will looks at me like I'm crazy. Like, why are you actually doing the work? Because you're supposed to, aren't you? You didn't get the memo? No? Yeah, you even grade your test back quick. I once graded it so quick during the pandemic. You know what I did? As students turned their test in during the pandemic in Canvas, as soon as I got them, I'd grade them. And they're like, what? Hey, can I redo my test? Because it's still test time. So really, by the time that test was over, everything was graded. People are like scratching their head like, what? Couldn't believe it. Isn't that funny? That's the kind of funny thing. It just reminds me of all of this. It just reminds me of everything. Just do your arithmetic, ladies and gentlemen. I didn't learn arithmetic until I took calculus. But don't tell the legislators that, because they'll just make arithmetic the prerequisite for calculus. And you guys know that's probably not a good idea. But those are the conversations I have to have now with people in the state. Oh. So you say, is that why you look the way you look? Yes. I have to have those conversations. What did they gave you? We're going to make it really hard on you. He said, you gave me the square root of x, and now you're going to give me 1 over the square root of x? Okay. What do? You're going to have to use a little bit of what here? I'm going to circle that. Use a little what? Algebra. Isn't that x to the minus 1/2? You guys with me on that one? You guys remember that from beginning algebra? Or intermediate, sorry. If it's a fraction power, that's intermediate algebra. If it's an integer, it's beginning algebra. So technically that's intermediate. Now, what does the power rule say you do with that new power here, right? You have to add 1. So you take the power and you add what? So yes, here, negative 1/2, negative 1/2, okay? And what do you got to do? Got to do some arithmetic. Okay. X to the what? Positive 1/2 divided by positive 1/2. And then you guys remember, you're really doing arithmetic here. It's a whole number divided by a what? By a fraction. So it's x to the 1/2 divided by 1/2. What does that give you? Isn't that going to be what? 2 squared root of x plus c? And there it is, ladies and gentlemen. You're finding what? Antiderivatives. What do you guys think? Easy peasy, lemon squeezy? It's just arithmetic.
Can you scroll up a bit?
Oh, sure. You see what I'm saying? I'm just doing arithmetic, and it's actually pre-algebra. All right. You say, what if they make it really hard on you, right? What if they said, okay, Mr. Judge, they gave me this function. It's x squared times the cube root of x. Now, all you guys have to use is what? And sometimes they'll do that, but okay. What do you guys know? It's kind of a trick question. What do I mean by that, right? What's the algebra here? Do you guys know? Isn't this what? X squared times x to the what? 1/3. And what is that going to be? Isn't it x to the 2 plus what? Which is x to the, is that 6/3 plus 1/3, which means I have x to the what? 7/3. You go, why did they just tell me that to begin with, right? They just want you to review beginning algebra, I guess, or intermediate because it's fractions. Okay? You have these, what's called rational powers, fraction power. Oh, right. Now, what's the power rule? Do you guys know? X to the what? 7/3 plus 1 over 7/3 plus 1. And what do you guys end up with? Anybody know? What do you guys get now? Do your arithmetic. 3/3. 3/3. What do you guys get? Isn't that x to the 10/3 over 10/3 plus c? All right. What do you guys think this answer is going to be? After doing a lot of these questions, you guys know what happens? You know, oh, that's 3 what? That's the reciprocal. Is that right? You guys okay with that? So after a while, that's what happens by doing this over and over again in your arithmetic. You start to go, okay, all right, I've seen this like 20 times. I think I'm going to put the reciprocal. But if you're kind of a little OCD like me, I would go through every detail when I first did calculus like this. I would actually write my division by a fraction. I'd write every gory detail, every step. And that helped me to be accurate, helped my accuracy. And then you're looking back at the book. I think I shared this with you guys, right? How do you simplify that? It's a very easy way to do it, right? How do you simplify these? And I don't even teach it. Well, when we used to have intermediate algebra.
You had it on your website, Algebra for Calculus Students?
Yeah, I did. Algebra for calculus students. I put that. Yeah. But I don't teach it in 125 though. Can't remember. But oh, if they had 125 still, I would do it. 10/3. What's 10/3? Remember, what did I do in that video, right? This is very helpful. You write the improper fraction as a what? Mixed number. Good, good. And that is your new what? So if you have x to the 10/3, it's really x to the 3 3/3. You say, hey, is it really x to the 3 3/3 instead? Yes. And then what is that? You say, well, that's, you guys know a mixed number. You guys know what the definition of a mixed number is? It's a whole number plus the fractional portion. So that's x to the 3rd plus 1/3, and then properties of exponents. So if you look in back of the book, you might see what? The antiderivative function going to be 3/10 x cubed cube root of x plus that constant c. And then that's just the algebra here, ladies and gentlemen. Easy peasy lemon what? Squeezy. So they gave you a complicated question It all came down to some arithmetic and some definitions. It's in your, you need to take a picture?
Oh, yeah.
Yeah. Yeah. All right, you guys okay with that? And, they do have some easier versions. You might say, what if they said, what do you mean easier versions? What if they give you this? Because like I said, it is simple, but you got to give it its time. What if they give you 1 over something like this, just x squared, All right. All right, you guys okay with that? What does this become? X to the negative 2. Is that right? So what's your antiderivative going to be? Take the negative 2 and you add 1. Take the negative 2 and you add 1 plus your constant. So what does that give you? X to the negative 1 over negative 1 plus the constant. Is that right? And then I'll say, what is this? Well, this is negative x to the minus 1 plus c. And what is x to the minus 1? Isn't that negative 1 over x plus c? So, ladies and gentlemen, this is how we start our career with what? Antiderivatives. What do you guys think? Not too bad? And I want you guys to give you guys an important note. Remember when I gave you guys that power rule? Right? Do you guys know what the only restriction on the power rule is? You see this function? If you write this in the format of the power rule, you say x to the minus 1 now, okay? And I want the antiderivative now, okay? What's the problem? It can't be negative. This is why they said, hey, do not let x be what? Negative 1. The reason you can't do that is because what's this? Can't divide by 0. You're trying to divide by 0, ladies and gentlemen, and it cannot be done. So just kind of share that with you guys. Okay, now, here's the deal. Here's another fact with antiderivatives. This fact has to do with addition and subtraction. I'm going to say this to you guys. I guess I could give it to you a few ways here. How did your book do it? If this is your function here, let's look at some properties. I'm going to call it properties of antiderivatives, okay? The first property is going to be, here's your function. They're going to give you a sum of two functions, and the question is going to be, what's your antiderivative? Well, it's very simple. It's that big F plus big G. So you get the antiderivatives what? Separate. Is that okay? You guys see my point? If they give you the difference of antiderivatives, well, do them separate. That's all.
Do we have to only include one C?
You're gonna see one C at the very end.
Oh,
Yes. And we'll talk about that because that's very common. That's something we have to get used to. And then you got this little c, and you go, well, what is little c? Well, we use c for a constant. So it's c times f of x. This is a different constant, by the way, this little c. So really, these are properties of antiderivatives, and it's not too bad. All you're doing is taking antiderivatives, okay, of the individual functions. So let's start off with a very simple example again. They say here's your function, pi x. And you go, pi x? Does anybody happen to know anything about the number pi? It's a constant. Good. So what's the antiderivative now? All you have to do is what? Write down the constant pi, ladies and gentlemen. You okay with that? And then use your what? Power rule. Because the power here is 1 if it's just x, right? So nothing's changed. What do you guys think? Pretty simple? So this would be 1/2 pi x squared plus c. Okay, you guys with me on this? Not too bad. All right. F of x is x squared minus x. Okay. You might say, well, what do I do now? And I apologize to you guys. This is what drives me crazy. You guys know what I'm talking about? It's not the same math. So I'm going to temporarily change this on you guys. I apologize. You might say, why did you just do that? Because I'm going to call this F, and I'm going to call this G. So it's kind of like saying, hey, here's H. Here's H. Here's an H, okay? H function. That's kind of what I'm doing because it's a different F, and it starts to get confusing. What F are they talking about? I got two Fs. Do you guys see my point? So you might say, I need big F, I need big G is my point. You guys okay with that? That's what I'm trying to say to you guys. So that means the antiderivative function big H will be 1/3 x cubed minus 1/2 x squared. Now this was the question that was asked. What do I put here? Well, okay, let's dive into the details here. Remember, I don't want to make my mistakes because I always make mistakes when I run out of room. This was the question earlier that was raised. Let's bring out our colors. See, I have to have the general form for F. And I have to have the general form for what? For G. Because there's a difference there between the two. I'm going to put a difference here. So really, Oops. Sorry. Sorry. Let me do every detail. All right, you guys good with that? This is my point to you guys. This is the f minus g we're talking about. Now, the question earlier was, what do I do with these constants? Well, when they start off, even when you read your book, they'll put a subscript. And they'll put a subscript. I'll give you every detail. Okay? We're going to do a little bit more algebra. And then the question becomes, what happens with your constants? I'm going to rearrange the terms. You see the C1 minus C2? You go, oh my gosh, what about these constants? What's going on there? Well, you know what you do? It's a constant. Call that C for constant. So at the end of the day, the antiderivative of this difference, 1/3 x cubed minus 1/2 x squared plus the constant c, you found that big H. Those big letters are the antiderivative notation when we first learned this. So this is the remark that was made earlier about my two constants, because you have to find the antiderivatives of the functions separately. You guys with me on that? So it can be very simple if you just say, hey, at the end of the day, can I just put my constant at the end? And I'll say, yes, just put your plus c. You say, but is c C1 minus C2? It is, but it's like saying, it's just a general way to describe a constant, right? 2 minus 7 is -5. It's still going to be a constant. That's all they're doing. And that's your first property of a difference here, right? So I'm going to try to give you a little bit more exact notation when you first learn this. And I'll go say, okay, here's your h now. What if they gave you x to the 4th plus x squared? And you go, but that's not f. I know, it's h. They want you to get the antiderivative of now the sum of two functions f and g, okay? It's a sum. Now, antiderivative notation. What do you do for each one of these? Do you guys know? You're going to do the antiderivative for x to the 4th. You'll do the antiderivative of what? X squared. You do them separately. The antiderivative of x to the 4th will be 1/5 x to the 5th. The antiderivative of x squared will be 1/3 x cubed, okay? And then I'm just going to put a big constant at the end. I'm not even going to bother with the C1s and C2s like you guys seen here. And this is actually following that property I shared with you guys, where this is big what? Big F, the antiderivative, plus big G. And don't forget, you're adding that constant at the very end. So notice how fast, quick, and easy working with these fundamentals will do for you with the arithmetic. If it's fractions, there's probably going to be more work. But if it's nice integer numbers, less work. Okay, you guys okay with this? Is that easy peasy? Still pretty simple? Told you today we're just learning some arithmetic. Or we're reviewing. What do they say? What do they give me? 2x cubed, Mr. Judge, plus 4x squared. How does that change my question now? Well, what do you guys do again? Here's what you guys do. These two are what? Aren't these constants? You're going to have 2. You're going to get the antiderivative there. plus 4. Get the antiderivative here. See what happens when I run out of space? I'm going to make a mistake, so I'm going to move it. Now add my constant c. So I want you guys to see exactly what we are doing. I need the antiderivative of x cubed. It goes right in here. I need the antiderivative of x squared. It goes right in here. You guys with me on that? And I have preserved my two what? Constants. What's x cubed? What's the antiderivative of x cubed? 1/4 x to the 4th. Oh, I'll put it here. What's the antiderivative of x squared? Let's do our arithmetic. Okay? You say, is that going to be 2/4 x to the 4th, 4/3 x cubed plus c? What's 2/4? 1/2 x to the 4th plus 4/3 x cubed plus c. And don't forget your constants are here and here. You just did some arithmetic. A whole number times a fraction. 4 times 1/3 is 4/3. 2 times 1/4 is 2/4, reduces to 1/2. And notice, didn't I put that plus constant at the end that I'm talking about? I don't even what? Put your C1 and C2. There it is. What do you guys think? Isn't that easy peasy lemon squeezy? Maybe I have to put, I'll put another property here for you guys. It's a really simple one. And I need to move up. I'm going to give you guys another property because it reminds me, because I just wrote this down. I don't think your book put the property like this at all, but I will. Right? What happens if they just give you a constant? What's the antiderivative? You guys know? It's going to be Cx. I'm going to share that with you guys why. Okay? Let's share that with you guys why that is. Let's go through the details. But before I do that, what do we have to do here? Do you guys know? This is really 3 times x to the minus 1/2. Is that right? And that's a minus, I guess. Minus 4. I'm going to put x to the 0. You guys know why that's x to the 0?
1.
That's really 1. So it's almost like we're saying here to you, you know, this is times 1. Okay? X to the 0. So we need the antiderivative where? What do we need here? This antiderivative and what? This antiderivative. Is that true? Keep your constants what? There. And subtraction. So let's try this out. Okay? Big H becomes 3. I'm going to say times the antiderivative minus 4 times that antiderivative. And I'm going to put the plus C over here. All right? So what do you guys know here? What's the antiderivative of x to the minus 1/2? X to the minus 1/2 plus 1 over negative 1/2 plus 1. This is x to the 0 plus 1 over 0 plus 1. Is that true? Double check. Are we okay with that? 3 x to the 1/2 over 1/2 minus 4x over 1. You say, can I put this over 1? Okay. And by now, you might say, is that 3 times 2 square root of x minus 4x plus c? It is. What's your final answer? 6 square root of x minus 4x plus c. So double check, ladies and gentlemen, if I've done the right arithmetic. Right? Don't forget, here, that's 2 square root of x. Is that right? Don't forget, here, isn't that just what? X? Okay, you guys know what I'm saying with a little bit of the algebra, and 3 times 2 is 6? What do you guys think? Easy peasy lemon squeezy? But I want to go back to this one. Anytime you have a constant, the antiderivative is going to always be the constant times the what? Times x. And it's because you write this x to the 0 power here. Right? This is what I do to demonstrate to people right there. That negative 4 becomes negative 4x. What do you guys think? Is that okay? What time do we get out of here?
55.
All right.
You have like a 7.
Okay, I'm going to ask this big question here. What about the trig functions? You go, oh no. Antiderivative of trig functions? Oh no. Let me share with you guys something here. You say, I'm going to have to deduce this. Let's do this here. Did you guys know, what if I differentiate sine? What's the derivative of sine? Isn't that cosine? You guys with me on this? So, here's what this actually means here. That's the big F. That's the little f in the definition. This is in the definition of anti-what? Derivative. Remember how we started that day? Right? Remember we started with the definition? You go, here's our definition. Like, wow, all the way up here. That's what I just gave you. So that's big F. Oops. I may have a typo. Sorry. Look at that. That's a big F. That's typo. Derivative of F of X. So that's big F. This is the antiderivative function we're looking here. So how that works is this. It's very simple. This is antiderivative. So if you said, let's write this down. And you want to memorize this here. Here's your function, cosine. What is the antiderivative of cosine? Sine. And I use big F for antiderivative. You guys okay with that one? As opposed to the word? And I could put plus C because it's the general form. But this is where it comes from. So all I got to do now, if you want to know the truth here, I'm going to go through all my functions. If I have to differentiate now cosine, what's the derivative of cosine? Yep. Now be careful here. I'm going to do something. I'm going to put that constant inside the cosine. You know what that's going to mean? Say, what did you just do? You see that concept by properties of derivatives? If I divide both sides by -1 or I multiply both sides by -1, here's my point to you guys. This is the antiderivative function, big F. And then this is your what? Function, little f. In the definition of antiderivatives. Oops, whatever. So if I go back now and say if your function is sine, you know what the antiderivative is? What is it? Negative what? Cosine. You want to know this like you know your name.
Time to change my name to Fred.
Yep. Yep. That's what I tell people. It's like you want to know it like you know your name because now they're going to say, hey, what's the antiderivative of sine? Negative cosine. What's the antiderivative of cosine? Oh, it's sine. So you want to know those things. And then what's the derivative of secant? Isn't that secant tangent? Is that true? Mm-hmm. So here is the function f, little f. And then here's your antiderivative what? Big F. So when the function is secant tangent, only when it's secant tangent, the antiderivative is secant. So they have to give you a what? A secant tangent. And then the antiderivative will be what? And that's the general antiderivative. All right, you guys okay with that? You want to know these like you know your name. Okay, what other derivatives do you guys know? Okay, what's the derivative of cosecant? Well, isn't it negative cosecant cotangent? So I'm going to get this out in red. Put the negative sign with cosecant. Now that gives you cosecant cotangent. So again, in your definition of antiderivative, here's the big F. There's a little f. So what we say really is if the derivative, if the function here is cosecant cotangent, you know the antiderivative was minus what? Cosecant plus constant. That's where they're getting it from. That's how you deduce it. So personally, I don't actually have these memorized. Well, I take that back. I do have some things memorized. You say, what do you have memorized? The derivative of trig functions is memorized. What's the derivative of tangent? What's the derivative of cotangent? So those are the things I have memorized. And I could then deduce the antiderivatives easily if I do that. So I just have to put the negative sign in front of cotangent so that we have this cosecant squared being without the negative sign. And again, you have what? These are antiderivative functions right in here. Those are satisfying the definition of big F. And then over here you have our what? Little f. So if the function is secant squared, what's the antiderivative? Tangent plus c. Is that right? If your function is cosecant squared, what's the antiderivative? Minus cotangent plus c. So everything up here in blue is antiderivatives. Everything up here in green are the given functions. So you're going to say, here's your function, little f. That's what they're going to give you. They're going to ask for all the antiderivative functions. And so, ladies and gentlemen, we're out of time. So I hope you guys enjoyed the first part of finding antiderivatives. Of course, we'll continue on what day. You know, and I did do some here, by the way. But I did put homework in Canvas. Is that right? Did you guys notice that? So you guys do have some homework. Let's say, I think it's called homework 4. Yes, it's published too. All right, ladies and gentlemen, I hope you're enjoying antiderivatives because we're going to be doing them for quite some time. So when do you want to get started on them? Yesterday. Good answer. Why? You want to do it the night before? Anybody ever learn that lesson? Do it the night before? It's horrible. Math can't be done that way. It just can't. And the difference between people who are successful at it and people who are not, that might be for some where it is. It's just a matter of your commitment and your time management. That's it. Can you go home and do the arithmetic now, review and study now? That's where the key is. And just on a personal note, you know, I know that a lot of students in these days, they're being kind of put in a position where they take a lot of units because the school says, you got to be out of here fast. They push them. They want to push you through, right? And I always have said this, it doesn't matter where you start. What matters is where you end. So I was never that crazy. I did only like 15 units once. And the rest of it was part-time for me. I think I did a few semesters, 12 units, blah, 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 whatever. But I never took more than like 2 math courses or a math science course and stuff. So I limited what I did because I knew I had to do the work. So it was a time management issue. But, you know, the way they have people think about everything now, it's just like, are you kidding me? So it's a very different approach, very different philosophy. My purpose was to learn. That's not really what happens these days, though. So anyway, just a little bit of something to think about. So we'll see you guys on Monday. Get started on your antiderivatives. We'll continue with our antiderivatives. Okay, good afternoon, ladies and gentlemen, or good morning, sorry. The faithful on Thanksgiving week. Good for you guys. So where did we leave off? Do you guys remember? We left off on computing what? What is this? Anti-what? Antiderivatives, okay? And we left off with giving you guys the antiderivatives for trig functions. All right, you guys okay with that? So, what I'm going to do this morning here, on a nice Thanksgiving week morning, is a nice warm-up to get nice and warm, because over Thanksgiving, I want you guys to work on some what? Antiderivatives, okay? You'll thank me for it later. You go, really? You say, you may not think you will, but trust me. Trust me, because this is going to be on your last test and final antiderivatives. So, determine the what? The antiderivatives. Alrighty. I'll say number one. F of x is the, let's say, sine plus cosine. 2. F of x is 1 minus 3 secant squared. 3. F of x is 3x plus cosine. Okay. I'm going to give you guys some examples of antiderivatives. And I'm going to get out my clock. We'll see how this goes. Come on. So, all right, ladies and gentlemen, let's try these out. What do you guys think? So I'm going to use colors again today because we're going to get the antiderivative of sine and the antiderivative of what? Cosine. Don't forget, we are using properties, and this is a sum. So what you guys really need to do is have this all memorized like you have your name memorized.
So we don't have to show how we kind of like convert.
No.
Oh,
No, let me show you what you guys can do here for this. And, you know, the notation again I'm using, it's a bit problematic. I won't go through the details. Who cares? But let me do this here. The antiderivative is big F. Is that true? So you got to know, what's the antiderivative of sine, first of all? I don't know. Let's see. What is it? Is it negative cosine? Derivative of cosine is minus sine. You're right. It's negative what? Negative cosine. You guys okay with that? And then don't forget, you say, what about this plus? This plus is there, but you need the antiderivative of what now? Cosine. What's that? Just sine. Now, always add at the end plus that c, and you go, I want to do the dance with C1 and C2. I'd say don't really go there. Fine. Okay, you don't have to. But ladies and gentlemen, here's kind of at the end of the day, this is what you're looking for. Sorry, let me get the colors out. Okay. All right, you guys see my point? You're done. Bless you. Bless you. You're done. What do you guys think? Okay? All right. Easy peasy? Good. All right, so now the next one, let's get this next one. All right, so I guess I'm going to try something here now. You might really say, I need the antiderivative of now what? The number 1, is that right? And then I got this subtraction operation. I have a constant, and then I need the antiderivative of secant squared. All right, so now that's going to be a big F. That's the antiderivative notation here. So what's the antiderivative of 1? Do you guys know? X. Good. And then you got this subtraction and the constant 3 there. So here's your antiderivative. What's the antiderivative of secant squared? Just tangent. And then at the end of the day, just put plus a what? Constant c. And that's it, ladies and gentlemen. You're done. All right, you guys okay with that? Is that easy? Yeah. All right. Let's go through number 3. All right, so very similarly, number 3, though, if we say, okay, we need the antiderivative of 3, you already have that constant here. I'm sorry, we need the antiderivative of x. You have the constant 3. Okay, let's see if we have audio. We have audio. And the operation is addition. We need the antiderivative of cosine. So big F. Keep the constant 3. Now, what's your antiderivative of x? Right, it's x to the first. What do you guys use? Power rule. So what is this going to be? 1/2 x squared. Okay. Your constant's already here, 3. All right. plus, what's the antiderivative of cosine? Just sine. And at the end, just put your what? Plus c. There it is. Now, you might even say, but what about 3 times 1/2? Okay. Write it as what? 3/2. And there you are. Easy peasy lemon what? Squeezy. Okay. What do you guys think? Not too bad? All right, let's see number 4 now. So number 4, you have now a constant here. And we have this operation of subtraction. And you got secant tangent. Let's find the antiderivative. So whenever you have a constant, what's the antiderivative of a constant? Because pi is a constant. It's just pi x, is that right? I mean, yeah, you got a constant there, okay. And then you have the subtraction operation. What's the antiderivative of secant tangent? All right, so then you have to finish this off with plus what? So, ladies and gentlemen, there you go. You're done. Easy peasy lemon squeezy. So aren't these actually easier? Are these easier than derivatives so far? I don't know. Number 5. Let's see if you guys can do number 5 here. So if we go through this, you say you have a constant here of a 2. I guess I need the antiderivative of sine. The operation is subtraction. Then I need the antiderivative of this 1 over the square root of x. And then I have an addition operation. And they gave me another constant out there. All right. Okay, let's get to work, okay? So antiderivative, you take that 2 constant. What's the antiderivative of sine? Negative cosine. Okay. And then you say, uh-oh, what is this? I'm going to have to rewrite this, right? This is going to be x to the minus what? 1/2 power. Is that true? So why do you guys think I wanted to rewrite that as x to the minus 1/2? Yeah, I'm going to do some arithmetic. So I have to know, if you wanted, it's negative 1/2 plus 1 over negative 1/2 plus 1, and then plus your pi x. Is that true? Then don't forget to add your what? Constant. So let me move everything over. All right. Okay. So negative 2, what? Cosine minus, this is x to the what? 1/2 divided by 1/2 plus pi x plus c. So we're almost done. What do we have to do? Anybody know? What do we do now? Isn't this going to be minus what? 2 square root of x plus pi x plus c? Right? Because you're taking a whole number and you're dividing by a what here? Divide by the fraction 1/2, you multiply by the reciprocal. And then x to the 1/2 is really defined to be, as a rational power, the square root of x. And there it is. Easy peasy lemon what? Squeezy. Anybody have any questions on these? No? Should we kick it up? So they have 6 here. They say, okay. They give us a function here like 6x to the 4th minus 3x squared plus 5. Everything over x squared. And you go, oh my God, what did they just do? 7 f of x will be 3x times the square root of x minus 2. 8. F of x will be 2x squared plus x minus 4. And I guess we're going to leave it like that here. Okay. We'll give you guys some time to try these out too again. And then we'll go over these. Maybe we'll do some more here. How about this? 8, 9, f of x will be 3 cotangent plus 2 pi, and 10 about pi cosecant cotangent plus 11. All right, we'll give you guys some time to try these out. Let's see what you get. All right, ladies and gentlemen, let's try this out. Number 6 here. First of all, what do you guys have to do first? Remember, there's no quotient rule. Okay, that's something that people think there's some sort of quotient rule. There's a rule for sums and differences, but there is no product or quotient rule. Okay, I'm going to say that again. So that we're going to see that over and over again. The point I'm making is you're going to have to do what with the algebra part? You guys remember? You're going to have to do what? This is kind of like what we call distribute your division. And the function then really is going to be what? X to, looks like it's 6x squared, right? 6x squared minus 3 plus 5 over x to the second power here. So you're going to have to do some beginning algebra. All right, you're going to do some beginning algebra first. Okay, you guys okay with that? And then so now, here's what happens here. You're going to get the antiderivative. Yes, the 6 constant is there. We'll say the antiderivative of x squared. Oh, of the constant 3. And then of what? Oh, we'll see what happens here with this, right? So, okay, so this is going to be 6 now. What rule do we use here for the x squared? We take the power rule. Is that right? The antiderivative of 3, isn't that 3x? And then here, you might say, can I write this as 5? Can I put that x to the minus 2 here? Is that right? And I'll say yes. So that's 5x to the negative 2 plus 1 by the power rule. And I'm finishing off with a constant. So, ladies and gentlemen, double check here. We're going to have to do every detail, right? So that's 6 times 1/3 x to the third minus 3x plus 5x to the negative 1 over negative 1 plus c. And then finally, ladies and gentlemen, it looks like this is going to be what? 2x cubed minus 3x minus 1 over 5x plus c. So does anybody have any questions on this one here that we just did? We had to start it off with a little algebra. What's that? Oops. The 5 should not be what? Down there. Good. All right. 5 over x. I apologize here. All right. What do you guys think? Is that okay? Was that easy peasy lemon squeezy? Is that too bad? You guys think? Not too bad? Antiderivatives? Okay, you know, some students are already checked out. They won't even do any antiderivatives. They're already tapped out. You guys know what I mean? Anybody tapped out already? Say, I don't even do antiderivatives. Thanksgiving's coming and... Anyway, hopefully you tell everybody what you're thankful for. Be thankful for antiderivatives. Remember, there's no algebra. There's no, there is algebra. There's no product rule. So you're going to have to use some algebra here. What am I saying? Distributive property. So distribute. Okay. What's that going to give you? Do you guys know? X to the first, x to the 1/2. That gives you what? 3x to the 1 plus 1/2. Is that right? Isn't that 3/2 then? So I'm just doing the algebra I need to do before I take my antiderivatives. Okay, now let's get some antiderivatives. What do you think we're going to get now, right? Keep your constant 3 and use the what? Power rule for antiderivatives. And this power is 1, so there'll be x to the 1 plus 1 over 1 plus 1 plus c. What's 3/2 plus 1? What's that going to be? 2/2, 2/2. You guys okay with that? All right. So this will be 5/2. Is that true? check. Okay. So what do you guys think is going to happen with this fraction? And then I'm going to do something here. Isn't this 2 and 1/2 if I write it as a mixed number? You guys know where I'm going with this? We got to simplify there. So this would be 6/5 x squared, square root of x, plus 3x squared plus c. And everybody okay with what just happened here? You guys remember I did that video for you guys here? Should I put it in pink? Pretty in pink? You guys don't like? Isn't 5/2 2.5? This is the 5/2, by the way. Okay, you guys good with that one? You guys see the point? Easy peasy lemon squeezy? All right. Let's do number 8 now. Yeah, I think it's listen, I think it's doable, but you know, you're going to have to do some a little bit of some work here, some arithmetic. All right, antiderivative. Keep the constant 2. Power rule. 2 plus 1. 2 plus 1. Power rule. 1 plus 1. 1 plus 1 minus that 4x plus c. Okay. Antiderivative. We get 2/3 x to the 3rd power plus 1/2 x squared minus 4x plus c. Double check, ladies and gentlemen. And there you go. Easy peasy lemon what? Lemon squeezy. Almost there. What do you guys think? You guys waiting for Thanksgiving?
Only 1 day break.
Only 1 day. Look, when I was a student, I remember my mother. You know what she'd say to me? Daniel, put your books away and eat some turkey. My mom would say that. What would I tell my mother? Mom, you don't understand. I got to do this. And she would still argue with me. Put your books away. Eat some what? Turkey. So I'd have to put them away for 5 seconds. And then I went back to doing my antiderivatives. So I could do them in my sleep. It's just how it was. I know it sounds crazy. I don't know. Maybe you guys are from a different generation. What generation are you guys? What are you called again?
Babies.
What are you?
Babies.
You're babies? You're the babies generation?
I think we're Gen Z.
Are you guys Gen Z? I have no idea. I don't even know what generation I am. But I know I'm not that generation that took everything. What's that generation? Do you guys know? What were they called? They took everything. No, the baby boomers. They took it all. They had everything and they took everything.
Bought their house for $1 in the 50s.
Or no, they had free education and free education, you know. And yeah, they messed everything up though. Those baby boomers. You guys notice that?
Yeah.
They had everything and now they took everything. Uh-oh. Those baby boomers. Yeah, I know. Jesus.
I think my grandmother is a baby boomer. She was born in 57.
Did she take everything?
She was in El Salvador.
Huh?
She was in El Salvador. There's not much to take.
There's not much to take. Yeah, I don't know. My parents are baby boomers. Well, they would be if they were still alive. Yeah. But anyway. Yeah, I know those baby boomers. Okay, 3. What's the antiderivative of cotangent? I'm sorry, cotangent squared.
Use property.
I don't know. Did I make a mistake because I'm not awake yet?
I don't think we went over that on Thursday.
I think, you know what?
I think we missed one, so we
It's
went
kind of
over
hard.
to-
Change it.
Oh, I think I messed up. Sorry, I messed up. You know what? In order to answer this question, you're going to have to take Calculus 2.
Oh no.
This is a Calculus 2 question. That's what I wanted to do, is trick you guys. There's no mistake here. This is a Calculus 2 question.
What do you solve it?
Can we still solve it?
Well, what's the... You know what? You can still do something, though. Can you?
Is there an
What's the identity? Is there an identity for cotangent squared?
1 minus
What's the identity? We might be able to do this one.
cosecant square minus 1.
Where are the math tutors in the room? They might come to you guys with this one. So let's see. Oops. Sorry, that's not even the antiderivative yet. Okay. So let's go back to the antiderivative list, because what we know is there a antiderivative for cosecant squared? There is. What is it? See this here? Antiderivative is minus cotangent. Man, they almost got us. Well, you guys have a couple of constants here. Is that true? I know you can't combine like terms with those constants. -3 is a constant. 2 pi is a constant. And then just finish this off plus c. So this is fine. And yeah, I guess we could do that one. Good.
So is this a calc 2?
No, it's calc 1 because you used an identity to get that. It's calculus 1. I wasn't focusing on the square. If it was just cotangent, calculus 1. I mean calculus 2. So here's what I was looking at, actually, if you guys want to know. What you'll see in like calculus 2 is they want you to differentiate cotangent. And they'll want you to differentiate tangent. So you might even, you'd have to find the antiderivatives of these functions. And you might say, boy, I can do sine and cosine. What about could get the antiderivatives for sine and cosine. What about cotangent and tangent? You got to take calculus what? 2. So you got to come back next semester. But don't do it in the winter. Probably shouldn't tell you. I'll have to turn in my math badge. Anybody here signed up for calculus 2 in the winter?
No.
They're going to get mad at me if I tell you the truth.
How are they gonna know?
Students don't keep secrets. They tell everybody everything. You kidding me? It's probably on social media right now. You know, that Mr. Judge, he told us don't take calculus 2 in winter. Anybody here know what I'm talking about? Have you ever taken calculus like 1 or 2 in the summer? 5 weeks? I would not. I would say to you, there's a lot of better use of your time. You could go hiking. That'd be probably better for you than take calculus 2 in the what? Winter or summer. That's crazy. You learn all this in 5 weeks? Really? Ain't gonna happen, ladies and gentlemen. Anyway. So if anybody ever tells you it's okay, what should I say you say? You can say this. Whose side are you on? Like, what are you talking about? Whose side are you on? Are you on a student side or are you on your own side? Whose side are you on? They're going to probably get a little nervous. Probably start sweating. Trust me on that one. I've argued with people on that one. With that one, I'm still going to in the future, but it's fun being right. Sometimes it's fun being right. You guys know what I mean? You know what I mean? You guys know? Huh? Sometimes it's fun, especially when they're wrong and they insist it and they know they're wrong and they want to hide it. Anyway, what's the antiderivative of cosecant cotangent? Huh? Is it? I don't know. What is it? Let's go back to our list. This is why you have to have that list memorized. Yes, minus cosecant. You guys see what I'm saying? If the function's cosecant cotangent, here's the antiderivative over here, minus cosecant. So you want to know that like you know your name.
Time to change my name to this.
Yep. I know. And then you got a nice constant, so you put your x and then plus a c. Is that true? Yeah. You know, it's funny because I had a student of mine in Calculus 1. I think it was Calculus 1, or did I have it in Trig? I can't remember. No, I had her in Trig. And I told the same students what I tell you guys. Don't take Calculus in 5 weeks. That's crazy. Because anyway. So, you know, that's kind of the general. I mean, I wouldn't tell my own children to do that. I mean, if you don't give that advice to your own kids, why would you give that advice to someone else? I mean, there's some ethical, I would say, should be some ethical concerns here. So if you're not going to give that advice to your kids, why would you tell someone else's kids that? Crazy. So anyway, the student got some advice from someone else to take it. Student did. You know what she told me? Mr. Judge, it was so horrible. I'll never do it again. I was thinking of changing my major. But thank you for your videos. That's what got me through it, was your videos. Well, I wouldn't have gotten through and I would have changed my major if... all because she just didn't listen to me. It's like, you don't have to change your major. You just have to do it right. It's simple. It's not hard. She got some bad advice. That you should have took the good advice. Anyway.
Did you ever take it, Floyd?
Huh?
Did you ever take it?
No, but I taught it.
You teach it during the winter and summer?
No. I'll tell you the story. I taught it. They talked me into doing it one summer years ago for like 5 weeks of Calculus 1 or I did it like Calculus 1, Calculus 2 or whatever. I did it and I said, oh my God, this is horrible. Horrible. You can't even teach it in 5 weeks, let alone learn it in 5 weeks. Horrible. Worst experience. So I went back to the department and I convinced them to do it for 10 weeks. If you're going to do a short-term calculus course, do it for 10 weeks. And back then, they didn't have winters. They only had summer sessions. So they did. They said, okay, we'll do it 10 weeks. And so we were doing it for 10 weeks, and perfectly fine. I did it for 10 weeks. Okay, that's doable, because like the quarter system has you do it for 10 weeks, you know. So it is doable. Can be done. And then, while I wasn't looking, some other people were teaching it. And they decided, I don't want to do 10 weeks calculus. That means I don't have a summer vacation. I want a vacation in summer. The instructor, not the student, instructor. So they changed it just so they can have some time off. And they didn't tell me. They did it all behind my back. Because they knew if I knew about it, I would get on their case about it. You know. So that's the reason why they did it. So they can have a vacation. I said, well, don't teach it. When you have a bigger vacation, let someone else do it. I said, no, I want to get paid during the summer, but I also want a vacation. So that's when I say to you, ask them, whose side are you on? Then they now have a 5-week winter. Whatever. It's crazy. It's how they do things sometimes. And they do it in the dark because they know I'll shame them in the public. Shame you. I hope your kids take 5-week calculus. Or I'll say even worse. Why are you not? Why do you do? Whoa. I'll say, wait. If you're not going to have your kids do it, why do you have these kids do it? Wait a minute. Let me start doing the math on this thing. Hold on. Let's take a step back. So I get them good. I get them really good. Sometimes I say, we got to do it for the students. And I get up and go, oh, come on, you guys. You guys know you don't do things with the students. Because if you did, they get embarrassed. Like, oh, shit. Darn it. So spread the word. Let them know. Calculus in 5 weeks is out. Just go have a good time. Go to the beach, whatever. It'll be a waste of your time. Your sanity is worth something. You know. Don't you think? You want to drive yourself crazy? It's not how fast you do things. It's not where you start. It's where you end. That's the most important thing is where you end. Anyway. So have you guys get started on your antiderivatives. I'll see you guys tomorrow. We'll talk about differential equations, and I hope you enjoyed every second as much as I have here. So we'll see you guys tomorrow.